In example 4b, we're going to differentiate this and we're going to use a product rule since we have a product of two functions. So I have my x function and I also have my arctan function. So I need to make sure I apply product rule. And inside the product, I have this embedded x rational function here. So differentiating this, I get y prime. I'm going to keep the negative outside. So I end up with the derivative of x, which is 1. And then I'm going to leave that arctan undifferentiated. So I end up with arctan of x over x plus 1. Plus, and I'm going to leave that x undifferentiated here. And then I'm going to differentiate the arctan. So when I differentiate the arctan, I'm going to end up with 1 over 1 plus x squared. Now that inside piece, however, is itself a function. In fact, I'm just going to, since that is an inside function, when I need to make sure I apply the chain rule when I differentiate this. So applying the chain rule here, it's going to be times, well, the derivative of the numerator, I need to use quotient rule, minus the numerator times the derivative of the denominator, and that's all going to be over the denominator squared. Okay, so there's lots going on here to simplify, but there is my derivative. Okay, so what I'm going to end up with is, I'm going to keep that negative factored out, so I end up with arctan x over x plus 1 plus, okay, so this part here, this just becomes x plus 1 minus x, which is just 1. So 1 times 1 times x, that's going to give me just x in the numerator of this expression. When I multiply the denominator, I'm going to get 1 times x plus 1 squared. So that 1 times x plus 1 squared is going to give me this. So this is going to be coming from this 1 here. Okay? And then plus, we have x squared over x plus 1 squared. Well, x plus 1 squareds cancel out, so I end up with x squared. And there is my simplified form of my derivative.